will be talking about the gang of 4 patterns. So we will continue with object-oriented design. And I've actually added the rest of the functionality in the blackjack game. And the design is, well, it's still the same. And that's always a good sign that you're kind of like your design is not revolutionary changed when you add functionality that it's supposed to be added. So if we take a look at the code, most of the changes are in the dealer class. This class is where I've added functionality for handling the hit and handling the stand. So when the dealer or when the player selects to get a new card, we have some checks, and then, well, the player gets a new card, basically. So we take the top card from the deck and show it and give it to the player. And consequently, when we have stand, we have a small algorithm here that says basically that when the dealer's score is below 17, he continues to take another card. And we have some helper functions, more or less, to decide when the game is over and to decide if the dealer is the winner of the game. And in the controller, of course, we have some handlings of the system events that the player wants to hit and that the player wants to stand. Nothing really revolutionary there. And we have this quite, I won't say advanced, but quite some new code here to present the state of the game in a good way. So we can present some special instructions depending on the state of the game. Have we started a game already? Well, then maybe we should not be able to start a new game. So we have a special menu for that. And also the actual code is in start game. So we have this check here also. And this is something that is often the case, that you have like the actual check is in the model, but you kind of like need to do this check also in the user interface because you would like to have a nice user interface that does not display options that you cannot really perform anyway. And we have some presentation also of the winner of the game. So if the game is over and we have a winner, we should display this. And also then the view, of course, has gotten a little bit more code in it to present the menu, and depending on the state of the game, we would like to just show hit and stand if the game is already started. If we don't have a started game, well, then you can select to start a new game or quit and not hit and stand. And we also have the presentation of the winner. So it should look something like this. So if I select to hit, nothing happens. If I select to stand, nothing happens. If I select to start a new game, we get the scores and we get the hands, and I should probably stand on that. The dealer will probably get a 10, so I guess the dealer will win, but hitting on 19 is risky. Yeah, the dealer won because he had a 10, so he got 20. So start a new game, and here we cannot start a new game again. Nothing happens. You just have hit and stand actually as options. Oh, 18. Yeah, I think we need to do that. So we got over 21, and then the dealer automatically plays. We have actually done all the requirements. We can play the game, we can have hit, and we can have stand, and we have also final result is presented that the dealer or player won the game. So the application is more or less done. However, now we get a new requirement. So to start the game, we have a variation. In Europe, the dealer actually does not get a second card. But in America, he gets the hidden card, and this is the implementation we have right now. So the question then is, how should we incorporate this new variation of starting the game in a good way? We would like to be able to ship different versions of the game to different types of customers. So it's not an option for the user to select what type of game to play, but rather our game is supposed to be able to support both of these types of playing, but it's okay to recompile the game to get these two different versions. So it's more of a design question. We could later maybe add if the user could select to play different types of games. But first things first. So how could we change the code to incorporate this? So okay, let's take a look at the code. We can always go back and look at the code. So it's basically this part here that needs to be changed. Start game. And we are kind of like supposed to remove this. Now we're the European dealer. Now we're the American dealer. So well, not a huge change. So leave comment. Good, bad. Yeah, probably not the best thing to kind of like remove stuff from the code by commenting it. So this is a no-no. If is add a member variable attribute, maybe send this attribute into the dealer when we start the game, and we can have this if statement here that says, well, if I'm the American type of dealer, then I should do this, otherwise not. The code would still actually be there in the final version in the European game, and having kind of like this dead part of the code is, well, we could imagine a case where this wastes some resources. So that could indeed be an argument. So in C++ we have the preprocessor, so it can actually remove code entirely, so it won't be compiled even. And that could be an option then. You can like define that, okay, this part of the code should not be even compiled when we have this variation of the game. So there are some flavors to this. It adds complexity. Well, we could imagine maybe this is quite a simple case, but we could imagine that we have a trickier case, and maybe we would have several kind of like if statements in here. Maybe we have more variations to start the game. Then we would need to add another kind of like if statement in this part of the code, and it would be kind of like messy. So even though this is fine and would work, both versions would work, I think. We should maybe think a little bit more about it. So, basically, we could think about this as the protected variations pattern. We have some variation or change, and we would like to design parts of the system to not impact other parts. So we would like to identify the points of variation, encapsulate the points in an interface in the broadest type of sense. So what we would like to do is kind of like extract this play game and put it in different parts of the code. And to do this, we can also use polymorphism, because we would not like really to have this if statement. We would not like to vary behavior based on the type of dealer. So we have protected variations that says encapsulate in some kind of interface, and we have this polymorphism pattern to say, well, you should assign the responsibility to polymorphic operations. And avoid extra states. Avoid this attribute is American dealer. Avoid type information and reflection. So, these two patterns, well, then maybe suggest, and we also have it in the chat here, to create some kind of abstraction and have this in this start game in a polymorphic operation. So let's just do that. Stop it. Oh, sorry. Too many languages. And we have kind of like the same thing here, so let's copy. And for now, let's just copy this whole operation. So, I think we are starting to... So something like that. We should get a compilation error because we cannot. Okay. Cannot instantiate an abstract class. So let's try it with the European type of dealer, and we will just remove this last part of the code here. And we can here see that, well, the dealer did not get a second hidden card as he should in the European version of the game. And we can seamlessly, I hope, just instantiate the American version. Compile and run. And we get the hidden card, second card to the dealer once more. And of course we have some code copying between these two. So maybe this should be refactored in some way. And we could have a base class maybe for both the American dealer and the European dealer to just have the small code variation at the end as the difference. But it will be a little bit maybe just adding more classes and code right now and not really proving my point. So, but in the real case, I would not like the code duplication here. But for now, we need to live with it, I think. So we could avoid having this kind of if statements and selection of algorithm based on type. Because this adds complexity into the dealer class. And given enough such checks, it will become really, really complicated. So we could use polymorphism and we could use protected variations to achieve this instead. Why didn't we have to change anything in the view or the controller? We did not need to touch those. Well, they're not dependent on which version of the game we actually play. They don't care. They just have the, well, as long as I get a dealer, I'm fine. I don't really care if this is the American version or the European version. So, and this is kind of neat, at least I think so, because we can change what happens kind of like behind the scenes, but the client, the user of these interfaces, does not need to know about how is this exactly done inside of it. So we have this concept of encapsulating variation, and the clients do not need to know about that at all. If we take a look at our class diagram once more, we have actually added 2 classes here. know what happened there. So let's just leave it. And this one is actually abstract now, so I think we have some way of showing that also. And super clearly, this one became in italics. So this is the new class diagram after these changes. And we can also here see that, well, the controller should not be affected by adding a new type of way of starting the game for these, since it's only dependent on the dealer and the player. We will look some more into this this problem as we go along, but right now we will just shift focus to the gang of 4 patterns. So, all right, gang of 4, Gamma, Elm, Johnson, and Blasides. Those are the bearded guys that, I guess they're bearded maybe now, that started the whole movement of using patterns in software. And they got their inspiration from a guy named Christoph Alexander that wrote a book about patterns in building architecture. Because he saw that, well, in building architecture we often have these recurring problems, and we have kind of like these standard solutions to these problems. They took inspiration from building architecture and a book on patterns there, and they saw that, well, we have this kind of like similar situation in software also. We have designed and developed large, big systems, and we seem to run into the same types of problems, and we can solve these problems in kind of like the same way. So they wrote this book about elements of reusable object-oriented software. So I also have it here. You should check it out if you're interested in patterns. The course literature has some of the patterns from this book also in it. And for you guys at the classroom, you can take a look at it. It's kind of old, but I think the principles still apply, and that's something that is good. You have quite a large example in it also on how to use design patterns, and this could also be good. The notation in it, as it's old, is not UML, but some other notation, but it's quite similar. So, but we will take a look at some of these patterns. And we have a few categories of patterns in the book. We have creational patterns, and if you remember to the grasp pattern, we have the creator pattern there that says, well, if this object contains objects of another type, maybe it should be the creator of these objects also. And we have some more creational patterns in the Gang of 4 book. And the idea is to help create objects encapsulate direct instantiation. So instead of using new object, blah, 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 we can use a creational pattern to encapsulate this in some good way, if we need it. And the patterns in bold are patterns that we will at least touch upon in the course. So we have abstract factory, builder, factory method, prototype, and singleton. Singleton is discussed in the book and also actually in the suggested solution for workshop number 2, so I won't be talking about singleton during the lectures. We have structural patterns, patterns that help you structure classes and compose objects in different kinds of ways to achieve your goals. And here we have adapter, bridge, composite, decorator, facade, flyweight, and proxy. Maybe some of these names kind of like ring a bell. They have tried to name it after stuff that is present in the real world, and maybe you have had an electrical socket adapter in some form, and basically what the adapter is for converting one type of class into another type of class, and that's exactly what the adapter for the electrical sockets also does. It converts some kind of current and voltage to another type of voltage. And maybe I also had this found kind of like these names in frameworks or stuff like that you have used. And we have behavioral patterns that help provide varying behavior. And in this department, we have a lot of patterns. Chain of responsibility, command, interpreter, iterator. Iterators should sound familiar, at least, I think. And this is a concept that has maybe even moved into programming languages, that you get iterators for collections automatically, more or less. Mediator, memento, observer. We have talked about observer already. State, strategy, template method, and visitor. So, to put these patterns in some type of context, we will continue a little bit further with the blackjack game. So, we have even more new requirements. Too bad it became a 1 there, but automatic lists are like this. So anyway, we should support many types of rule variations. We have this rule variation for starting a new game. We already have implemented the variation there for American and European. We could imagine more ways to start this. We can have rule variations for who wins the game. For example, who should win if they have an equal score. This could be a way to vary the rules in the game. We could have different types of rules for when the dealer actually takes a card. Should he take card on up to 18? Should he take cards just to 15? We have actually a rule that is called soft 17. That is about what the dealer should take a card when he has 17 if he has an ace that is counted as 11. Because if he then gets a card to become with a value 10, the ace could be counted as 1 also. So he would still have 17. This is actually the rule that you will implement for workshop number 3. But we can imagine having these points of variations for different kinds of rules in this game. And if we look at the code, it would more or less mean that, well, we have some variation of this, because this is right now a very simple algorithm of the dealer taking a new card as long as he has not gotten a score that is higher than 16. So if the score is below 17, he just continues to get, this should of course be removed. He just continues to take cards. And also for this part of the code, who is the winner in different types of situations? And we could imagine several kinds of scenarios here. If you have the ace of spades, you're automatically the winner. And stuff like that. So we will have multiple points of variation for these rules, and we should also find a design that supports adding new types of variations that we really don't know about right now.